All right, so we're looking at dividing by polynomials. And so first thing we're going to look at is how long division worked. Because long division is where we get the process that best works on this. So if we look at 7,824 divided by 31. Long division was a process where we had to focus on the place values and use the place values to hold what we're looking at. So we have 3 in the tens, and so we're going to look at each place value that comes across. So when you have 31, you need to figure out how often it goes into 7,000. And so the first place we end up actually looking at is that 31 can't go into 7, but it can go into 78 twice. But notice how this is in the place value for the hundreds. So we're saying that 31 goes into 78,000 200 times. So, but we're using the place values to hold everything. So we're not keeping all the zeros with us. We're doing everything in columns on the place values. And so we're working our way from the higher place values to the lower place values. And this will come in handy in polynomials because in polynomials we have a place value that's associated with the degree of each term. So 2 times 31 is 62. 2 times 3, 1 is 2, 2 times 3 is 6. We subtract these, which gives me 16. So I bring down the 2. And now I have 162. Well, it's really in the tens place, so it's like 1,620. But again, we're letting the place that the numbers occupy carry all that information from us. We're not worried about where the zeros are because the place has taken care of it for us. So 31 goes into 162 5 times. 5 times 1 is 5. 5 times 3 is 15. And we subtract again. So that's 7. Now we bring down the 4. Again, letting place values do all the work for us. And 31 goes into 74 2 times. 2 times 1 is 2, 62. So we do our subtraction again, and we have 12. And we could say that that was 252 with a remainder of 12. Or we could say it was 252, and that remainder we can turn into a fraction of 12/31. And we've sometimes seen the number written this way. And that's the technique that we use for polynomials. We're going to let the place, in the case of a polynomial, be the degree part of the polynomial. And we'll use the degree part to complete our division. So we have a procedure that we're going to do. So you want to focus only on the first term for each step. So we're only focus on the first term. So you will divide the first term of the inside polynomial by the first term the outside polynomial. So we're only dealing with the first term that's ever presented, and you'll see how that'll work through. When we do that division, we will get the value we need, and that we place on top. So we then multiply the term on top by the entire outside polynomial. Now let me get the word outside looking like the word outside polynomial. So we multiply the term on top by the entire outside polynomial. Subtract the result of step 2 from our polynomial. Bring down the next term. Wow, my letters are not coming through clear right now. Next term, there we go. Just have to slow down my pen hand a bit. This forms a new polynomial on the inside. New poly. I'll just say poly for polynomial here. And now we repeat. Repeat. Just like we repeat in long division until there's no digits, we repeat until there are no terms left. No terms left. So this is a loop that we run through and we keep repeating. So let's do this on an actual polynomial. So I could say I have x squared. It's going to be our example, so I'll draw my weird little line here. X squared plus 7x plus 10 divided by x plus 2. Now I have to notice the denominator is not a monomial, it's a polynomial. So I cannot do it the way we did with monomials. So I'm going to rewrite this like a long division. So I'm going to make a division bar. I'll put x plus 2 on the outside. And on the inside, I'm going to put x squared plus 7x plus 10. Now, it is important that I have each degree represented here. They hold places, just like numbers hold, digits hold places in a number. Each degree in a polynomial is important in the division. So I have to go from the exponent second degree term to a first degree term to a 0 degree term. I will need each of those terms represented. So over on the side here, I want to look, my first step says, we'll scroll back up, first step says focus only on one term. Divide the first term of the inside polynomial by the first term of the outside polynomial. So come back down here. Here is the first term of the outside polynomial, first term of the inside. So we will divide x squared by x. The answer to that is x. So we write this up here. And that was step one. All right. Now, step two says multiply the term on top by the entire outside polynomial. I'm going to do that in yellow. So the outside polynomial is x plus 2. So I want x times x plus 2. I want to distribute that. So I'm doing work off on the side here, and I want to carry it all back off in the center where we're actually doing the problem. So x times x is x squared, and x times 2 is 2x. And so there I've done step 2. Step 3, subtract the result of step 2 from our polynomial. Now let's see. I've written the result of step 2 here in yellow. So now I'm going to subtract. So again, I'm going to change color for each step here, so we get a lot of color in here. Sorry about that. So subtraction, my signs are going to change. So x squared minus x is 0, which is good. This should be happening. This is why we choose to focus on the first term, as we should be zeroing out here. And then 7x minus 2x is 5x. So my new polynomial doesn't have anything up front here. And I'm starting with 5x. And so my next step says bring down the 10 plus 10. So bring that down. And now I'm at the point where I have to repeat. So I've done my subtraction, I brought down my 10, I have to repeat. Well, I have a new polynomial here. So my steps were in red. I want to shift over slightly in orange. I'm still looking at the first term in this polynomial, but this is my new polynomial, and this is my new first term. So I need to do 5x divided by x. And my answer is 5. So I bring that up here. Now I multiply this by this entire polynomial, so we'll make this a greenie. 5 times x, so I'll write it down here, 5 times x plus 2. It's starting to get to the point where I'm scrolling a bit here. Let's see if I can get that up. There we go. 5x plus 2. So I'm going to do that multiplication. Let's come up and down a bit here. I'm a little, so 5 times x, so 5 times x is 5x. 5 times 2 is 10. So my next step is to subtract. Oops, change my color here, sorry. So each step gets a color. I'm going to subtract these. 5x minus 5x is 0. And 10 minus 10 is 0. So I have no remainder, which is good. If I look up top, I have my answer, x plus 5. So x squared plus 7x plus 10 divided by x plus 2 is x plus 5. And we can double check this. I'll do my double checking down here. X plus 2 times x plus 5 using FOIL is x squared plus 5x plus 2x plus 10, which is, which is when I combine these like terms, x squared plus 7x plus 10, hey, that's what we started with, x squared plus 7x plus 10. So when we divide polynomials by other polynomials, we can use the technique we used in long division. But we have to make sure that we have a place for each degree of x, and that we go 2, 1, 0. They hold places in this process just like the ones, the tens, and the hundreds place do in larger numbers. In the next video, we're going to look at dividing with a remainder, and we'll look at some other examples here.